So now, in this SAS case, so this is the SAS case. We know this side, and the one included angle. Then the next step is to find the smaller angle of the alpha and the beta. So right now we know the gamma, right? We need to find the alpha and beta. So which one we take on first? We first find the smaller one between the alpha and the beta. So find the smaller angle of alpha and beta. Since we have the A less than C and less than B, then we have the alpha less than gamma less than beta. So now, in the expression alpha plus beta plus gamma, if I replace beta gamma by this smallest angle alpha, so definitely this sum is greater than alpha plus alpha plus alpha, right? Beta bigger than alpha, gamma bigger than alpha. So you have this quantity. And this guy is equal to 180 degrees. So from here, we have such an inequality, 3 alpha less than 180 degrees. And this just implies alpha is less than 60 degrees. So alpha must be an acute angle. Okay. So now we can use the law of the sines to find this alpha. Sine alpha is equal to A times sine gamma over C. And this is equal to 1.3 times sine 9.8 degrees divided by 13.6. And this is approximately equal to 0.0163. Then alpha in this case is equal to arc sine of this 0.0163. We just need to find the acute solution for this equation, okay, because alpha is acute angle. So this is approximately equal to 0.9 degrees. And then you find the third angle, beta, which is equal to 180 degrees minus gamma minus alpha. So it's the 180 degrees minus gamma. Gamma here is equal to, hold on, 9.8 degrees. Right, and the alpha is equal to 0.9 degrees. So this beta is equal to 169.3 degrees. Now let's look at page 592. Let's look at this procedure for the case SAS. So if you know the sides B and C, also the alpha, the angle alpha, step 1, find A using the law of cosines. Okay, we just done this, right? And step 2, use the law of sines to find the beta if the B less than C. So in this case, alpha is known. You need to find the beta and the gamma. So you compare beta with gamma. B less than C, then beta definitely is smaller than smaller than gamma, right? So in this case, you find the smaller angle beta. But if the C is smaller than B, then gamma is smaller than beta. So in this case, you find the gamma. In any way, you find the smaller angle of the two remaining angles. And if the B equals C, then find either beta or gamma. Doesn't matter. Okay. Then step 3, find the last angle by subtracting the first two from the y-axis. Then in this case, you find the third side and the two remaining angles. In the last section, we have learned one area formula for the triangle, which we obtain from the law of the sines. So area equal to 1/2 times B times C times sine alpha. All this guy is equal to 1/2 times AC times sine beta, or equal to 1/2 times AB times sine gamma. Now, let's briefly introduce a new area formula for a triangle if we know the three sides. So if we know the three sides, then first we get the half, the perimeter of this triangle. So that is the A plus B plus C divided by 2. And we denote this half the perimeter of the triangle by this small s. Then the area A of this triangle is equal to the square root of this s times s minus A and times s minus B and times s minus C. And this formula is called the Heron's formula. Now let's look at the one problem. Let's look at the 32. And we know the A is equal to 7, and B is equal to 8, and C is equal to 5. Then find the area. So we can use this Heron's formula. And first we get this S, which is equal to 1/2 times A plus B plus C. So this is equal to 1/2 times 7 plus 8 plus 5. And this is equal to 10. Then you plug in all these values into this Heron's formula to get the area. A is equal to square root of S times S minus A times S minus B times S minus C. And you have the square root of 10 times 10 minus 7 times 10 minus 8, and then times 10 minus 5. Then you simplify, you get the area, which is equal to 10 times the square root of 3. Now, let's look one word problem. It's on the page 597, problem 42. It's about flying. It says, Andrea and Carlos left the airport at the same time. Andrea flew at 180 miles per hour on a course with the bearing 80 degrees. Let's first draw the bearing of the course of Andrea. So this is the page 597 Problem 42. So we first draw the one ray pointing due north. Right. And this bearing is equal to 80 degrees. So this is the cos for Andrea.